Yeah, so this isn't on a closed interval, so when it says find the extrema, we just want to find places where the graph changes direction. So we need to find the critical numbers. Critical numbers are where the first derivative is 0 or undefined. Right? So the first derivative should be derivative 2x is 2. Then minus 2/3 times 3 would just be 2x. Subtract 1 from 2/3, you get negative 1/3. So 5. All right, so this is really 2 minus 2 over the cube root of x, right? X to the 1/3 means cube root. So I see where you guys are getting your 1. Right, because if you put 1 in fraction, you get 2 minus 2. So 1's a critical number, but we're also, another critical number is 0.
Oh,
Because it's where it's 0 undefined. And if I multiplied this top and bottom by the cube root of x, right, this would be 2 cube root of x minus 2 over the cube root of x. Right, so 2, when you think about a test, on the test Thursday, when you're just asked to find the derivative, you could write the derivative like this. I would be okay with that. On the take-home, they would probably do this. They'd make it one thing. You know, you wouldn't necessarily have to do this for me. This would be fine. But this is nicer to do now if you're thinking about critical numbers. Critical numbers are where the first derivative is 0 or undefined. So if you have a fraction, it's where the fraction is 0 or the denominator is 0. Right, so really what we got to do is take the 2 cube root of x minus 2, set that equal to 0. Right, and that's where we get x is 1. Or the cube root of x could be 0. That's where you get x is 0. So these are our critical numbers. Call them critical numbers because that's where the first derivative is 0 or undefined. A lot of times people forget to look for where it's undefined.
That's right.
So now if we go back to do our points, okay, when x is 0, if we put 0 in here, we get 0. Right, and if x is 1, put 1 in there, we get 2 minus 3, we get negative 1. So this one, 0, 0, I'm thinking is probably the relative minimum. Or relative maximum, this is the relative minimum.
So, wait, you don't substitute those back in the original equation?
No, I did. Yeah.
No. Never mind, I substituted in the wrong equation.
Yeah, don't-
Disregard.
Yeah, don't put it in the first derivative, put it back in the
Yeah.
original equation.
No,
All right, now you guys, we
disregard
can
mine.
check these with our calculator too. You know, that's always a good way to learn too, is confirm stuff on the calculator. If we come in here to the y equals, put 2x minus 3x, and then to raise that, I do a little caret, and I got to put the 2/3 in parentheses. Right, if I just raise it to the 2/3, it will square it, then divide by 3. I want to raise it to the 2 divided by 3. Then I'm going to go to zoom 6, because we've changed the window on a different problem. There's the graph. And see, it does some weird stuff right in here. Right, but it goes up, then it goes down. As long as it's on the screen there, the calculator, if you go to calculate, so second trace, it will find the maximum, number 4. Just make sure the cursor is to the left of it. So I see my cursor's to the left, hit enter, and then move it so it goes to the right. Okay, now it's past where it looked like it was highest, so I enter again, ignore guess, hit enter. Now, here's where the calculator really, I don't know why it does this. It's saying 2.3058 e to the negative 6. That means move the decimal point 6 places to the left. It's 0.502. That's 0. Right? So is this. That's 0. So its maximum's at 0, 0. Right? I've yet to be able to figure out why this calculator does it. And yours, when you do that, you might get numbers like that, but a little different. Depending on, where you had your cursor. But this is really saying X is 0 and Y is 0.
Could you zoom in and you could pretty much see that too? When you're on the calculator?
Yeah, let's try it. Like I like zoom. How about zoom box? Do you ever do zoom box? I like that. Watch your zoom box at number 1. You move the cursor where you want to start making a box. So maybe I'll start it right there. Hit enter. And then you can make a box around just what you want to look at. So if we just want to zoom in on that part and hit enter again, it will just graph that part. See, even with this, it doesn't look like it goes to 0, 0. But it does. There's some flaw in the calculator. I don't know why it's not doing that. But if I do second calc maximum. Right,
Can you just trace it to X equals 0?
yeah, I bet we could.
Yeah.
Let's see, I'm moving the cursor. Now let's go over here. I'm to the left, I'll enter. Then to the right. Right, so you can see when I watch this cursor, it goes above where it looks like the graph goes to. Then it goes down. Get to the right, hit enter again. See, this time it says 3.22 e to the negative. That's put in scientific notation, that's 0. Let's see, if we hit trace, we can actually just put 0 in there, huh? Tells us it does go to 0, 0. All right, and it shows us that's at that point. Then we can find this minimum here, do second, trace to get to calculate. Number 3 is a minimum. Cursor's to the left of the lowest point, hit enter, and then just skew to the right until you get past the lowest point. All right, so I'm past it, hit enter, ignore guess, hit enter again. Gives us 1. Ignore this little extra point, 1, 1. 1, negative 1. That was our minimum. Now, to speed that up too, what I could do, when we're in here, when I do second, calculate, let's say I wanted to go back and find the minimum again. Okay, instead of moving the cursor around, I know it's 0 on to the left of that. I can just put 0 in for the left bound, hit enter. And then clearly over here at 3, I'm past it. I can hit 3, hit enter, ignore the guess, and it will find the lowest point in between 0 and 3. All right, so that saves me some time instead of moving the little cursor.
And to be able to do that, you hit second, trace.
Yep. You got to get into calculate.
Yeah.
Get into calculate. That's where we go to find derivatives, integrals on the graph, intersections, maximums, minimums, zeros.
Okay.
Plethora of things we can do.